Hello. So we are live for. Hello, this is Michel from Switzerland, and we are live for a coding session. So let's code. We are coding the Michelium blockchain. So this is today what we want to do is that we want to help visualizing a little bit the blocks. Let me show you what the block is. So we are running on IPFS network right now. So let me pull out the browser. And so it's like a mutable file system where you place document, and every document is cryptographically secure with the hash keys that you see below, like it's the QM, something like that. That's the way IPFS hash the document. So there's two documents, document.txt and document1. So it's two blockchain, and we want to merge those two blockchain. So the first document contains this version D. It has a location where we indicate the source, so it's public test document, and so in the file we indicate where to place it. There is the previous version of that document. Not previous version, previous block in the chain. And the previous version is the parent where it comes from. But yeah, actually here it's identical. And so there's the current hash of the current document, and there is also the previous version that we have the same hash than those ones. And there's some other fields. Anyway, so that's for the documents, and there's a document one. Document one is different versions. It has different parents and previous because it belongs to a different chain, and obviously it has a different hash for itself. So this is those things, and then if you want to walk through the trees of different, or walk through the chain, you have to take every hash and then go and fetch every document manually, so it's a little bit tedious. So if I replace the hash here and I look at it, so this is the version C. If I want to go to the previous one, I go there and replace the hash in the address bar. And this is the document B. And if I go to previous, and this is document A. Okay, so document A has a previous, and I think it's probably itself. So we want to look at it. Document A, yeah, it's itself, but without the previous field because we didn't know there was previous field. And this one, the parent, so where the document A come from. Nowhere. It's probably an empty file, so it's come from an empty file. Okay, so here you have all the chains, so A, B, C, well, C, yes, and the other branch B1, and so on. And so it's a little bit difficult to visualize, I mean, how is the version of the trees, how is the blockchain, and so let's write a little script to view this in a more graphical way, okay? So I will remove the browser and let's go there. And so what I already started coding a little bit. So for what I want to have a program that is called tree, and where I pass in argument the head of blockchains. And so I can loop on all the heads of blockchains. And what I want to get the block corresponding to that head. So the head will be in a format of a symbolic MFS, mutable file system link. So for instance, it will be, let's say, usage tree.pl, and I will do, for instance, public test documents.txt, and I can put several of them if I want to see everything on the same, several blockchain on the same graph, and I will be test document 1.txt. Okay, and so from those symbolic name, I need to get the hash of the block, so the address on the IPFS network. So that will be convert IP MFS name into IPFS addresses. Okay, let's put 12. And so let's write this thing, and I want to have this into a package called IPMS for interplanetary mutable system. And so let's go there and add the function that I need. There are already tons of functions there, but every time I need a new one, I can place it there. So let's see, I have a get content or get hash something already that we see that we did the other time. There you go. So we can place get key. What get keys mean? The key list. Well, I get address here. That's perfect. The subroutine get address. So what we have is we have a MFS path. MFS path. And we want to do a stat basically to get EPFS stat to get the hash. So we call the EPMS API with files stat with an argument that will be the file name MFS path, and with some options. I forgot the options. It's probably hash equals 1. Yes, something like that. And we see, well, let's debug it. So we want to have a print image, and we call it YML. I mean, I've assumed that the answers are in YML format. We will see if it's not the case. MH return MH maybe hash, but I don't know yet. We'll see. We'll see what's going on here. And so let's test it. Let's go into the shell. VI test. Deeper. I need to call the library, so use lib. That will be in the environment variable home, and followed by lib. So that's where the libs reside, and then I can use the package I just have, IPMS, and I want to use the function get address there. And so well, let's do it, I'll do the hard way for testing my and pass / public test document.txt, and we will call it my address equals get address and pass, and printf address and we're done. Okay, so let's do test.pl. Did I call it differently? That's weird. I think I didn't save. Okay, so boom, 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 error, message, file does not exist. Well, I made probably a mistake. Let's check. Yeah, probably I have to source the thing. Source the min and setup. Per test. IPMS files stat slash public test. This exists. Documents text. This exists too. Oh, because by default we go on the wrong API. PMS API. Yeah. Okay. I go. Yeah, I need to get the proper IP addresses. So right now what we can do is probably just hard-coded this with the right 21 or 22, I don't know exactly. MS config API addresses. No, it's addresses API, no? Yes. So 21, 25, 21. There you go. So with the proper gateway port, I get the hash of the file that I asked for in my test PL document, test script. Okay, so it does work, and it does return a hash with all the thing for the statistic. Let's see if I can go back to get get address and suppress the print and leave debug. Okay. So we're done with that. Then we can go back to our tree. So block. So I get the block for the heads, And that's it. Yeah, that's perfect. Then I get the content. Then I get from the content, I get the source, extract the keyword source. And then I will go for each block. I will go get the parents. And if I have not seen the block, I will get the payload, the previews, display the previews, build the graph, and then loop by setting up blocks equals to parents. Okay, let's try that. So, which directory is an example? So, mini chain example merging, and there is a tree.pl. So perl tree.pl, and so did you say, let's copy paste those things. Yeah. So what did he do? Public documents. Oh, did I put the same? Yeah, I put the same. So we have to put document 1 on one side. There you go. So document 1, you find the hash, it find the payload, find the previous one. These are short form of hash, meaning I took the 5 first character and the 4 last one. And the parents is this one, which is this one. Previous this one, this one. So we go all through the parents chain. And at the end, this one as a parent of that one, which is no offline file. And then document one as this version, and the parent is this one, and then this one. Okay, let's look at the graph. And so eog tree.png, and so what we have, document 1. I don't know if you can see the image. I can make it bigger maybe. Probably I have to recenter it for you guys. And maybe make it shorter so you can see. There you go. I mean, roughly. So what do we have here? Let's go on the top. So document 1 with all those versions. So every time a previous link and the parent link. On dotted line is the parent link, on the plain line is the previous link. So the previous link is the blockchain itself. And so it has a previous, and it has a previous ancestor that is common to the other chain, and up to the genesis block, which is the first block, is this one, because it has a parent of this one and there is no previous. Okay, and on the other side of the chain, we have the same thing with documents. So the head point to this one, point to this one, point to this one, point to this one, and up to that one, which is the first one. So they have a trunk that is in common here, and they branch out different paths from here. Okay, sounds good. So now we have a visualization. So now we want to merge this document with this one. And what we want is detect that the common ancestors is this one, so that we can apply the modification on that branch and the modification on that branch to be able to have the merged version. Okay, so let's see if we can do the test case for that merge. And do we have the merging thing also? Well, let's try Perl. Merge. Oh, wait. Here. -V. Okay. Push the fs brings bin. Is the merge here? Yes, the program we wrote last time. So what is in the foo thing? Oh, that's the important. And foo. What do we do here? We want to do push d plus 1, and we want to do Perl merge, and the hash of the both things that I don't remember. Let's go and grab the hashes from the website. And so here the file test. So the first document, let's do refresh to make sure we have the last version. It's kind of slow. And go to document 1, no, document. So that's the file version D. We can copy hash. I think I have hard copied the hashes in the test, in the merge file. Yes. So the first document will be this hash. Come on. Here you go. Oops, I made it twice. Okay. And the second document, there will be the document 1. So document 1 and copy hash. And we want to change this one with the new hash. It's not the same. Copy paste is always a little bit tricky, huh? With the heteroclite. Oh, and the video makes us also even slower. So copy hash, here you go. It's 1E at the end. So if I go there and I do middle mouse and I have 1E. Okay, here you go. So we will merge those two documents by running the Perl script. Perl ~1/merge. And so what did it say? It went through the first tree, it detects the ancestors, and then it goes through the second one, detect the ancestors, And there is no common ancestors. Okay, so I need to debug that a little bit, and I will come back if you want to cut together the solution if I have found where it's come from. Okay, well, see you and reconnect for testing that merge.